So as he alluded to, is we're going to talk about predictive analytics today. Let's share this. Good. All right. Alrighty. So with predictive analytics, the four kind of points or high value propositions in which predictive analytics aims to accomplish is to provide a solution that is predictive in that it can catch early warning issues with pieces of equipment, performance, where it can identify, drifting performance markers of your assets. And how it usually does that is off of a baseline, off of historical data when those assets are running normally or in a healthy manner. And then, aside from getting the data, it's, correctly identifying the appropriate issue that is actually taking place with all this, AI engine running in the background. And that's accomplished with that prescriptive high level proposition. And then once you've identified the issue, you want to, be able to properly, deploy the appropriate prognostics for handling that situation. Are you able to, for example, are you able to wait to maintain that asset during the next scheduled downtime, or do you have to wait or make an unscheduled planned downtime because the trajectory of that failure is going to be sooner than what you guys currently have scheduled? So predictive analytics is a supervised machine learning tool, and what it does is uses advanced pattern recognition. And so, as I mentioned before, it uses existing historical data from sensors and other pieces of information, a part of that asset in a data-driven model, as opposed to maybe a physics-driven model where you have to do some more advanced calculations, be knowledgeable in being, what it means to be a data scientist. So the data-driven model really allows for kind of a user-friendly approach to handling predictive analytics. So by the very nature of what predictive analytics means is it's early warning detection. So of that early warning detection, it's crucial to implement, a good strategy to handling these early warnings versus, a traditional alarm, which might signify a real issue that's happening in real time, whereas early warning gives you a little bit of leeway to handle that issue. But it's critical to have a good strategy to handle those early warning detections, to avoid them becoming, nuisance warnings, or, I'm going to disregard it later because it's not that big of an issue. So, really employing a proper strategy is a good method to have a good, successful implementation of predictive analytics. And just recently, AVEVA's offered predictive analytics in the cloud. So you can have an on-premise version, which has existed for several years now, a cloud version, or even a hybrid approach, leveraging, AVEVA Insight, which Mike just presented on previously, or, other historians, whether it's our historian, other existing historians out there on the market, SQL databases, or even, CSV files. So one of the problems with doing, advanced analytics without a piece of software like Prism or Predictive Analytics is kind of finding the needle in the haystack. You have this multivariate relationship, and identifying the problem or identifying a drifting trend in the problem can be very resource intensive in terms of finding that particular issue. And so what predictive analytics aims to do is make a user-friendly approach to, use AI and have, you know, that AI engine identify that issue, and then properly move forward in handling that, you know, moving forward with you and your entire team at your facility. So what predictive analytics does is notice the subtle changes between the actual value and the predicted value that it's generated from that model building. And the differences between the two kind of signify, you know, an asset that might be slowly drifting outside of its normal health parameter. And so by putting all those, you know, individual deviations together, you kind of build, you know, what's kind of model and a overall health indicator that identifies, you know, is the asset running properly. So traditionally in a SCADA system, you have your data set and you have these, you know, kind of wide range alarms that signify, you know, critical issues that, you know, have happened to a particular piece of equipment, whether a bearing, you know, broke, or, you know, some type of issue with a motor, or performance issues with another piece of equipment. But there's a lot of room for analysis to catch that issue a lot sooner. And how this is done is, you know, if you think about this in terms of screen resolution, right? With a traditional alarm, right? We might have 1 pixel, very low resolution of what's really happening with our data. But if we add more pixels and group those areas into smaller sections, we gain higher resolution of what's really happening with our data. And by doing so, we can then provide that early warning detection. Is, you know, if the data drifts outside of any of those boxes, you know, the Prism software is going to alert me, hey, there's something going on here, you know, do some further investigation as to what might be causing it, and then properly, you know, handle that potential issue. So as I mentioned previously, there's a few different ways of predictive analytics handles certain types of indicators, or, you know, providing some summary information on what's happening. So the first thing is you have this overall model residual, and it's kind of a compilation of specific tags within a model and those deviations between the actual and predicted values. And it performs a calculation to provide an overall asset health indicator. Essentially, think of it like a check engine light. You know, if, you know, the check engine light on your car provides a, you know, indication that something is going on within your car, but, you know, until some further investigation, you know, doesn't necessarily point to what might be causing the issue. Now, other indicators that are within the software are, you know, individual deviation alerts for a specific tag. So within the model, you can break down into the specific tags that make up the model and see, you know, the deviations from the predicted and actual values individually at a tag level. And then thirdly, it employs fault diagnostics. And all that means is you can identify and define specific relationships between those tags to represent specific types of issues for specific equipment. That meaning, you know, if the bearing temperature is deviated from normal, and maybe it's higher than normal, and the bearing vibration has deviated either higher or lower than normal, and maybe the coolant temperature has remained unchanged within maybe a turbine engine, maybe that might relate to some type of performance issue relating into that specific piece of equipment. And those specific relationships would relate to that specific fault diagnostic. So the core features of predictive analytics. You have, as I mentioned, the early warning and event detection. So in this web browser, you have a web client, you have a alarms management page. So you have all the list of all the different alarms for all your various models for your given assets. And they have, various things like different, indicators suggesting the severity of the alarm, as well as the type of alarm that might be going on for that specific model, as well as some summary information, like a snapshot of, flags for certain indicators of certain models. So these red and green sections represent, when a specific model was in either just a low warning or a, high alarm, more severe alarm for that specific model. So then once you identify an alarm or want to investigate it, you can drill in and see the specific contributions for that specific model. So up at the top, you have the OMR, the overall model residual, which I mentioned previously, which is that check engine light, right? The overall asset health of that specific model. And then down below, you have the individual signal contribution for those individual tags that are contributing to this OMR. Now, based on this screenshot, it can be safe to assume that this first individual tag is probably contributing to a larger portion of this unhealthy asset state just by the larger deviation contribution to that model. And so doing some further analysis, you can have some, likely fault conditions. So as, issues arise, predictive analytics, analyzes those issues and spits out likely fault diagnostics that have been pre-configured for those assets. Think of it like a WebMD. You type in your symptoms and it'll give you a list of potential issues that you might be sick with. And the different bars represent a either maximum chance that it's contributing to, that's the likely contributor fault diagnostic, or the average contribution. Down below it, you have a bar chart with, represent signal contribution. So that's kind of giving a different depiction of, which tags are contributing the most to the potential issue. Down at the bottom, you have a snapshot of the current trend of the asset. And, it's been flagged for when that OMR has been signaled for either a warning or a high alarm. And then you have some summary data of all this information up in the top right. And so as you investigate an ongoing issue, you have a tool called case management. And what case management is designed to do is a few different things. Coordinate with your team. You may be the analyst of analyzing these alarms and models. Coordinating with maybe a maintenance team and the supervisor team or management team of the progress or current state of this investigation of this early warning detection. And there's fields where you can share comments and make sure follow up with people to ensure that they followed up on specific tasks, as well as as cases get resolved, you can assign dollar values to the ROI of what you saved because you caught that particular issue early. And it's really a great tool to really define the ROI, for upper management, proving that the software that you've purchased is providing a good, return on investment, saving you money in terms of, reducing downtime, increasing your performance of your assets, and preventing those critical failures that might, provide a large dollar value, sunk cost where, production might stop down, or this particular asset is maybe expensive to fix. And then there's some out-of-the-box reporting that we provide, as well as you can generate your own reports which leverage SSRS. So what defines a model? Essentially a model is a logical collection of tags, and those logical collection of tags take into account not only the asset itself, but where does it reside in the whole process? What's upstream that might be affecting the asset, what's downstream that might be affecting it, and taking all this knowledge and properly selecting the appropriate tags, using those kind of concepts is what defines a model. And as you can see, the model can be, something that might be process related, that, track maybe a flow or temperature or maybe pressures, or even, maybe a mechanical model, which, track bearing vibrations or bearing temperatures, those types of mechanical processes. And because assets can be, fairly simple or, complex, and, depending on the amount of data that's available for those assets, an asset can have more than one model. And so you can see some examples. So something like a pump might just have, one or two models of just mechanical and process, but maybe a gas turbine might have, 4 or even 5 models associated to a particular asset. So revisiting those 4 value props of prescriptive, those 4 Ps. And first off, with prescriptive, right? We saw this same screenshot that we saw before. Just identifying that signal impact. Identifying potential upstream or downstream implications, as to further identify maybe the severity of the issue that might be taking place. And these root cause fault diagnostics and root cause relationships and prescriptive next steps, AVEVA really has collected and gathered a whole library of common assets and fault diagnostics that you can leverage within your system. Now, not all asset is the same, or not all asset is common. Some are more unique than others, and it's definitely possible to create your own template or library that leverages those new assets that might not be encompassing within the predefined library of available assets. So prognostics. As I mentioned, right, with that prognostics portion, you want to be able to, first identify there's an issue, but then identify, how quickly that issue might progress into a more severe alarm. So what predictive analytics does is project that trend of where that actual value will end up and how fast it'll end up onto maybe a critical alarm. And from there, as I mentioned, you can then take that information and better identify how to handle that specific issue. Can I wait till this next scheduled downtime to take a look at it and save some cost? Or do I need to have an unscheduled downtime and plan appropriately ahead of time before that next maintenance that is scheduled? And so it uses this deep learning model, and the key thing is that it makes it easy to use. I don't have to create or calculate an advanced calculation. I use the engine that the software provides to generate this trend analysis. So in this demo, in the web client, we are on the alerts page, alerts management page. And there's been an issue with the steam turbine engine and particularly the performance of it. And so we're going to drill into it. And it's been correlating for an issue with two particular tags, which are the inlet flow and the steam turbine temperature. And so what you can see is the actual value and the predicted value for these individual tags. And then in the OMR, right, you have the different highlighted sections have been flagged for either early warning for the light yellow, or for the red is that maximum warning. And the yellow and red dash lines represent those thresholds that triggered the specific issues. So if you see the green trend, as it dips below that red dash line, which is the high alarm limit, it'll signify that that's just in the early warning or low warning phase. But as the values dip below the low value warning phase, it's considered still a healthy asset. So leveraging the asset, right, you can see this individual signal contribution as well as that likely fault diagnostic. In this case, we've only identified, the system's only identified one likely fault diagnostic, and the green section is that maximum likely contribution percentage for this specific efficiency degradation fault diagnostic, whereas the blue is the average. In this case, it's 83.1%. So we can, fairly safely assume that, this particular fault diagnostic is the likely cause or issue that's going on within our particular asset that's been identified by this individual model. And so as you further identify some prescription, you can have a further description of what this fault diagnostic might mean, as well as the next steps you want to take to either maintain that asset or identify, potential next steps into how you want to manage the asset. And then, as I mentioned, you can utilize this trend projection, where in this case, it's going to project, the data about a month moving forward from where we currently are, and identify how quickly the data is going to reach that limit alarm, or that critical limit alarm, where it'll identify, system failure, or that critical downtime where the asset breaks and causes that high dollar value loss, or critical production stoppage where you can't even continue production. And so based off that, you can leverage that information. It seems like based on where we might be, in this case it was done in early January, and if it's going to project to have an issue sometime mid-March, we can use that information to further identify how we should handle the projected issue. So some key takeaways are and benefits of predictive analytics are a few just main points, right? The goal is to reduce that unplanned downtime, to prevent equipment failure, particularly when it comes to critical assets, to really optimize your maintenance strategy when it comes to not only just equipment failure, but as well as performance of those assets. So that's something that predictive analytics can do is monitor when performance degradation occurs, and if it's a critical asset, slight performance issues or degradations can have a very quantitative impact of production, of throughput, of key performance indicators of output values. And then ultimately, the goal is to reduce costs and risk for those critical assets. Making sure that those critical assets are as available as possible, and and reducing that risk, knowing that you can safely run operations and plan for operations, knowing that those critical assets won't go into an unplanned downtime. With that said, if there are any questions, I'll go ahead and field those now.
Yeah, hi Tim, thank you. Great presentation. We did have a question in the Q&A. Are there any applications for predictive analytics or examples in the water and wastewater industry?
Yeah, absolutely. In the water wastewater industry, for example, we were working with a customer. They wanted to implement predictive analytics for their high pressure booster pumps. And if an issue with they had several of these high pressure booster pumps and other types of assets that they wanted to model. And if an issue went to these high pressure booster pumps, they would have to do an unplanned crane schedule, which because you're not scheduling it, would have a high dollar value associated. I think the customer was saying every time they have to call a crane, it's an $80,000 cost just in the crane itself. But not only that, then further repair of maybe more damage that might have occurred than what maybe might have been mitigated had predictive analytics been there ahead of time.
Awesome, thank you, Tim.